Last time we looked at frequency distribution tables, and today we'll be looking at the probability distribution tables. The probability distribution tables. So just to review, let's look at the data we looked at last time. So we had 4 male teachers, so these are all teachers. 4 male teachers and 6 female teachers, and then we had, if I remember correctly, 24 male students and 26 female students. Okay, so this was the frequency. We organized this into a frequency table. The first time we just organized it into teachers and students. So there are 10 teachers total and 50 students total. And the way to do this is that we have the position on one section and the frequency in the other section. And we have teachers, there are 10 teachers, and we have students. Yeah, 50 students. Then we had the total. The total was 60 people. Okay, so this gives us the frequency. This tells us how many of the people at the school are teachers and how many are students. But sometimes we don't need the specific number, but we're more concerned about the percentage. So what percent of the school are teachers? What percent of the school are students? Right? Sometimes finding the percentage gives us a better information than the specific number. So this is called a probability distribution table. So this part stays the same, the position stays the same, but instead of putting the frequency, we put the probability. The probability, so the position is teachers and students. And we can also put the total down here. To get the probability, what you need to do is divide the frequency by the total. Okay, so for the teacher's part, we can just do 10 divided by 60. And that should give you about 0.17, right? 0.17 or 17%, if you want to put it in percentage, 0.17. For the student part, again, you put the frequency, you divide the frequency by the total, and you're going to get 0.83. And you can kind of check the probabilities. Remember, for probability, 2 things needed to be true. One is that it has to be between 0 and 1. So if you get a negative number, or if you get a number bigger than 1, it means you did something wrong. And another thing is they have to add up to 1. So if you add these 2 probabilities, 0.17 and 0.83, it has to equal 1 or 1.00, which in this case it does. Okay, so we that doesn't guarantee that it's correct, but it's more likely that it's correct if these 2 conditions are met. Okay, so always keep these 2 in mind. If you get a probability that's bigger than 1, it means you did something wrong. If the 2 probabilities don't add up to 1, it means you did something wrong. Now, sometimes you can get, if you add them up, you might get something like 0.99 or 1.01 because you might have rounded them which if it comes out like this, just make sure that you did your calculations properly without any mistakes. And if you didn't make any mistakes, then it's okay. Right? Just make sure, double check, you need to be double careful that you've rounded them correctly. But usually it should come very close to 1 or equal to 1. Ideally, it should actually equal 1 without any rounding. Okay, so let's do this probability distribution table for including the male and female information here. Okay, so let's start with the frequency distribution table. Remember, we had the gender on one side and then the position on the other side. I'm just going to use T and S for teachers and students. Oops. Put them closer together. And then M and F for male and female. And remember, we had the marginal frequencies here. And then we had the grand total down here. Okay, so male teachers. There are 4 male teachers and 6 female teachers. There are 24 male students and 26 female students. And then we added them together. So this should give you the total number of teachers, the total number of students. This should give you the total number of male and the total number of female. And if you add them all together, oops, sorry, this shouldn't be 60, this should be 50. If you add them all together, the grand total is 60. Let me actually put this in red. That's the grand total. So a probability distribution table, you can label them the same. Let me make enough space for the total. You can label them the same, except instead of the frequency, we're putting the probability. Okay, so to get the probability of each of these, divide each of them by the grand total. So divide each of these by 60. So for this one, you're going to be doing 4 divided by 60. Which is going to equal about 0.07. For the female, it's going to be 6 divided by 60, which is 0.1. Okay, and 24 divided by 60. Let me actually include the work here so that you will be following along well. And also so that I'm not making mistakes. That's 0.4, and 26 divided by 60, that is going to be 0.43. So again, you can check if each of these are between 0 and 1. They should be between 0 and 1. Okay, and then let's find the total on this side. You just add up the probabilities this way. Okay, so 0.07 plus 0.1, that's going to be 0.17. If you add it up again this way, you're going to get 0.4 plus 0.43, you're going to get 0.83. And add down like this, it's going to be 0.47. Add down like that, it's going to be 0.53. And for the grand total, again, it's similar to the frequency table that we did. You can either add like this or like this. If you add it like this vertically, then you can use the horizontal method to check if you did it correctly. And the grand total should be 1. And in this case, it does equal 1. Okay, so the same rule applies. Each of the individual probabilities should be between 0 and 1. And the grand total should be 1. When you add them all together, it should be 1. Okay, so what can we learn from this probability distribution table? We can learn that male teachers are about 0.07 or 7% of the whole school. Female teachers are 0.1 or 10% of the whole school. Male students consist about 40%, and female students about 43%. The total number of teachers, or the teachers, are about 17% of the total. We did this before, actually. We had this information before. And 83% are students, 47% are male, and 53% are female. Okay, so we get a different kind of information from when we have the frequency distribution table. For frequency distribution table, we know the exact number of each of these. But for the probability distribution table, we know the percentage or the probability of each of those. And actually, as the data gets bigger and bigger, the probability distribution is going to be more useful, because the number, once it gets too big, then it's very hard to intuitively grasp the data, and probability is going to be much more easier information to deal with. Okay, so this is how you can draw the probability distribution table given the data.